Please welcome our first speaker from the day. It's Dima from Subsquid.
Hello, everyone. There are not that many people today, but I hope that everyone that come here had a great days in Amsterdam. So probably others are having more of a hangover, but it's like a good day. And today I'm going to talk about the future of on-chain data access. I'm Dima from Subsquid. I'm a technical co-founder and CEO. Before we start, let's just observe how the data infrastructure follows the hype waves of crypto and how the things go together hand in hand and how one thing reinforces the other. So remember mt.gox hack in 2014. A lot of funds were stolen, and soon after chain analysis, a data forensics platform was launched as a response to the desire to actually track the funds and get the first insights of what's going on-chain. That was just Bitcoin back then. 2016, Infura launched at DEF CON 2, and that was one of the key enablers of the ICO craze that followed in 2017, because that actually allowed people to do first airdrops, collect money, and that was the key infrastructure piece to get these funds moving. In 2020, we all had DeFi summer, and congrats everyone who earned on this and got hefty gains on this. And that was one of the key wave that propelled the projects such as the Graph or Dune Analytics to where they are. Basically, that a lot of DeFi projects relied on the infrastructure to quickly spin off different forks, gather the insights, and that was the first time where we had a lot of data on Ethereum that we could also have a closer look from the analytics point of view. And now it's 2022. So we live in a multi-chain world. We have parachains, L2s, bridges, and we're seeing that exponentially complex dApps are emerging in the space. And I argue, and what we're going to talk today is that these new challenges, and this new wave of genuinely new use cases require different data infrastructure and different solutions compared to what we already have. So let's observe what is the state of the art when it comes to data indexing today. So typically a dApp doesn't really go directly to the blockchain node as long as it's not a trivial thing. Usually there is a middleware in between which enriches and transforms the raw on-chain data into something that the front end can speak to. So usually you have a middleware which ingests raw transaction data from the blockchain. Then it transforms into something on the business level object. So in this particular case, if you have a NFT marketplace, then raw transaction data coming from the blockchain is transformed in entities like a dog or cat or whatever NFTs are about. And when you have your web UI, you actually ask about NFTs owned by a specific account, and you expect that the answer would be dogs, cats, but not the raw transaction bytes. And the data indexing task is to actually enable this intermediary piece that actually converts the raw on-chain data into something that the web UI can consume easily. So it all started with a very straightforward approach where you have a blockchain node and you source this data through a big monolithic node which in our case, handled everything through like Polka.js. Then you have to deal with low gRPC nodes. They're like breaking types, bundles, breaking releases, and there are like two key issues with this setup, even though it works pretty well for relatively simple dApps. First, as any monolithic system, it doesn't scale because you cannot really add more processing power together with the storage and together with the GraphQL server because everything is packed like a single brick. You cannot really extend it indefinitely. And the second major drawback is that you cannot really build anything complex with such an approach because whenever you change anything in your, with your API, you have to wait sometimes a few days before it's getting in sync. So like a dev experience is something like this. You change something and then you just like wait for hours and sometimes days. So this is like what makes us at Subsquid to introduce a modular architecture for data indexing. So there are two key pieces, like a fat archives, which actually store pre-indexed data from blockchain, and there are Squid processors that share, they may share different archives, and they're pretty lightweight, so you actually can iterate and change your APIs much faster compared to the monolithic design. So let's unpack the fat archive thesis and why I believe this is the right level of abstraction and key module in here. So first of all, it turns out that pre-indexed on-chain data that is accessible as a GraphQL API is just the right level of abstraction because it gives you all the insights into the raw data compared to the blockchain on one hand, and on the other hand, it is fully compatible to all other downstream applications. The next insight is that these fat archives, they offload all the heavy lifting from all the downside pipelines to the processor. So it actually deals with data storage and data retrieval for all the downstream. And the key insight here is that this is actually scalable because storage is cheap, because you can add more nodes in your cluster. And the second is like this data is static. So it is very easy to decentralize this piece. And it is also much easier to verify the data integrity compared to all the downstream stages where the data is already transformed. So this intermediary step is very good at offloading all the things that are common to all the APIs and the processors. And last but not least is it turns out that having all your on-chain data indexed and available at your fingertips becomes an ultimate development tool whenever you are having a dApp or like a chain that you are building. Actually, there, like to our surprise, HydroDX guys threw like a whole workshop about this, like even today, I think at 5 or like earlier, dedicated directly on how these archives are used in the development. It looks very simple from the user point of view. So you have a GraphQL playground, and you can query pretty much any information that you would normally go look at Subscan or some other explorers. But the key difference is that you basically can query arbitrary data and build arbitrary complex requests and get instant insight into what's actually going on chain. Like in here, you, for example, have all the extrinsics signed by a specific address, and then you can order them by the block number, and you can also join all the events in there, and you instantly get all the information in the decoded way and exactly the way to store it by runtime. So this is like a key step of the indexing pipeline, which is now becomes modular. OK, now let's unpack the Squid Processor part, which is a plug-in that is sitting on top of the archive. So these are two completely different pieces. And the Squid processor is something that you often change, because this is what is responsible to making your API customized to your dApp. So you have a schema which defines the shape of your API, and you can easily change this, adding some fields, new entities, new table, and this is like as flexible as it can get. So key insight here is that since we are sourcing data not from the blockchain, but from the archive, we can do very efficient batching, and not only at the data extraction level, but also in transformation. So we can actually extract and aggregate in huge batches rather than just like doing it sequentially one by one. And that can improve synchronization times up to 100x. Another design solution that we have taken at Subsquid is like we made everything as an open and permissionless SDK, in the sense that we do not limit what is possible to do in an execution environment. So for example, you can enrich data with some external APIs like CoinGecko. You have full control and full access to the underlying database, so you can add triggers, add any scripts running on a schedule and timeline. So everything is open, and you have direct access to the data, and you can even offload it from the database. And finally, the API that you get is amenable to extensions were custom resolvers. So if you want any functionality that is not covered by out-of-the-box GraphQL server, which already comes in with all the filtering and pagination that you would usually expect from a GraphQL API, you can add arbitrary query, and that will execute a SQL query against the database that you're working with. So this is really an SDK that allows you to build everything that you would usually do in like a Web 2 world, like without no limitation whatsoever. Okay, so this is like how it works, and I believe this is like the state of the art today. But let's look at the unique challenges that we meet right now as the ecosystem evolves. So first of all, very high transaction throughput is the new normal. So we should be accustomed that there are like thousands of transactions per second, and I'm not talking about like single chain, but also in a situation where we have like an L2 layer, or we have different parachains accepting transactions simultaneously, and we're actually interested in all of them in the API. The next challenge is that we really need sub-second latencies from our API, in the sense that the time between the transaction coming to the blockchain and the time it's reflected by the API should be milliseconds, not minutes, not seconds. And this is required, and it will enable like games and all other dApps where real-time experience is crucial. You cannot really build a game if you have like your like stats changing only like 1 minute after like I make a frag. And another challenge is data fragmentation. So right now we don't have like a single chain like Ethereum where everything lives. We have lots of chains, parachains, and L2s, and the user data is fragmented across it. And when we want to make an API, we want to get this information from different data sources. And finally, the apps require more and more processing power and more sophisticated algos in order to deal with this data. It's not only just like filter, count, max, or like aggregate functions that you run against the database, but we need recommendation systems, we need machine learning algorithms, we need social graphs. And that actually requires not just like Postgres or any other general purpose database, but this requires like specific database like a graph Neo4j. So let's see how these challenges are addressed by the modular architecture that we're building at Subsquid. So our multi-chain archives will be able to source the transactions from different parachains in the canonical order directed by the relay chain. Because the relay chain actually knows in which order the transactions should be processed, and then you can source the transactions simultaneously at the same time, ensuring that the order isn't deterministic. Another point is that, as I mentioned, our archives are horizontally scalable when it comes to the storage and retrieval. So it is something that is impossible to do if you pack everything in monolithic node, because each node would store like a terabytes of data. But in our archives, there are clusters. And they're horizontally scalable, so then you can just like add more nodes if you want more storage without compromising the scalability in like how much queries you can get. And the crucial insight is that you can actually not only offload data storage and data retrieval to the archives, but with the right tools, you can also offload execution, which would make the synchronization times go down to minutes or even seconds, because most of the time the custom transformation that we require at the processing side is parallelizable, and this is something that is already used in like Web2 world and the Spark environments and like all other cluster deployments. And this is the power that we can offload to the clusters of archives, relieving like the most intensive work, not only from the data perspective, but also from the processing side. So this enables us to process millions of transactions into a single shot within just minutes, something that is impossible to do in a monolithic architecture where you actually just have to go through one by one. Let's see what can be done on the processor side. So the key issue with the processor is like it takes time to process, even when it comes to the head block. And there is an issue with parachain finality, because whenever you have a parachain, you usually have to wait like a few minutes before the block is finalized. So the processor should be optimistically looking forward and index non-finalized blocks, so then you have experience of your data being instant. And if there is a fork or there is a rollback, the processor should be clever enough to roll back all the logic that's been applied to non-finalized blocks and apply the other one. This will enable everything being an instant and accommodate like thousands of TPS. And finally, not only the processor in the archives itself, but also tooling for local testing and continuous integration is currently missing on the market. And this is also a key enabler for building complex dApps, because you have to be sure that your data is sound. And here also the modular architecture is what it makes it possible, because instead of trying to spin up a node and retrieve data from the node, you can actually have a proxy for your archive. And this makes the tests reproducible and at the same time very easy to spin up and test. So you can reduce this integration tests from like hours running to just like seconds, because everything is stored locally and you can inspect the data and you can prove it. You can prove that the data is not broken and even automate it as a GitHub action, for example. So summing up, I hope I have convinced you that the modular architecture for data indexing is exactly what we're heading into, and this is the right way to think about data indexing when it comes to complex dApps and applications that we are seeing right now. And to wrap up, we have archives which are responsible for horizontally scalable data access to the raw data, how it's stored in the blockchain, and we have processors which enables you to very fast iteration on the API that is tailor-fit to your particular dApp or like dashboard. Here are GitHub links, dev chat links, and also I'm very happy to announce that we have our own tech Subsquid on the recently launched Substack exchange. Our dev team constantly monitors these questions and instantly can answer. Finally, I'm happy to announce that there will be a dedicated workshop by our dev advocate Massimo today, so please don't miss it. Massimo will go into details of how to run your Squid, how to connect to the archive, and how to make your API tailor fit into your application. Thank you very much.